Hi, you guys. I'm here with a few hints and tips for the calculation section of the stoichiometry lab. So the first two questions have to do with the stoichiometry part of this lab. So you're going to calculate a theoretical amount of both products that should be produced. You're going to use stoichiometry to do it. And you want to start with your limiting reactant. So we measured a specific amount of aluminum. And then we added excess copper chloride. So you're going to start with the grams value of your aluminum. Remember, if you had some aluminum left and you subtracted out that value, you want to start with that subtracted value. And then you're going to convert from aluminum to aluminum chloride, which is aqueous. And then you are also, a second equation, going to convert from aluminum to your solid copper. And remember, we collected the copper. So if you have not measured the mass of your copper at this point, you can go into the hood and grab your copper and get a final mass, because you're going to need that for number two. So number two, you're going to calculate your percent yield of copper. So you're going to need your experimental value. That's what you're actually going to measure. So that's your actual value of copper that you collected. And you're going to divide that by the theoretical value that you just calculated in number one. I have a feeling that our values are not going to be amazing just from how dark the samples were already. Remember, that dark color is copper oxide. So I'm thinking that they might be a little bit high than they actually should be. So that's the stoichiometry part of it. So now we want to do the heat part, which is what this chapter is about. So we're going to calculate the heat given off by the reaction using our experimental data. So what we need to remember is that heat lost by the reaction is going to equal the heat gained by the water. So this heat value of our water is going to be equal to the negative heat of the reaction. We know this is an exothermic reaction because our solution heated up. And with our reaction, we need to take into consideration the amount of heat that our calorimeter is absorbing. So we're going to take that heat of the water, and then we're going to add back in the amount from our calorimeter that we calibrated on day one of this lab. So we'll start by using our water values. So we're going to take the mass of our water. We all used 50 grams, but again, make sure you use your exact value, times the specific heat of liquid water, which is our 4.18 joules per gram degree Celsius. And then we're going to take our change in temperatures. So you're going to take your final temperature, your higher temperature, minus your initial temperature, and that's going to give you your heat of reaction, the negative of that, right? So this will be a positive value. That's the water, and then it'll be equal to your negative heat of reaction. Now, remember, when we did our calorimeter calibration, we realized that that heat that the water gained was not exactly equal to the heat that was lost by the other sample of water. So for the second part, we need to add back in that heat that was lost. So you calculated in part one the heat capacity of your calorimeter, and that was in joules per degree Celsius. So what we need to do now is take that value, and I think most of you had a value of like maybe 200 to 400, I think. No, that was total. So then you divided that by degrees Celsius. So you'll have a smaller value than that. But you're going to multiply back in the amount of the temperature change. So you want to get rid of this degrees Celsius part. So you're going to take your heat capacity from part one, and you're going to multiply it by the total change in temperature of this reaction. So every degree that it goes up, you're losing a certain amount of energy in joules. So what you're going to be left with is joules for the entire reaction. So at this point, you can add together the Q of your reaction and the Q of your calorimeter. They're both should be negative values. So the Q of your reaction, it's exothermic releasing heat. And then you're going to add back to it how much heat the calorimeter kind of stole. So it should be a large negative number when you're done. Now, we want to get this value somewhere that we can compare. So in your pre-lab, you calculated the heat of reaction for this one using known values. And our known values were in kilojoules per mole. And so we need to get it to that. So right now you have a joules value. So we need to get it to joules per gram. So you're going to go to joules per gram of aluminum. So you're going to divide your answer by the grams of aluminum that you used. So then you'll be left in joules per gram. Then to get to joules per mole, you're going to use the molar mass of the aluminum to convert from grams to moles. So you'll need to multiply by the molar mass. And then finally, to get from kilojoules to moles, you're going to use the conversion 1,000 joules equals 1 kilojoule. Then you should have a value that's in kilojoules per mole. Make sure that you are showing your work and canceling units at each step so that you know exactly what you're left with and if you've done it correctly. Now that kilojoules per mole value is going to be compared to the kilojoules per mole value that you found in your pre-lab. I believe it was pre-lab question number 3. So we're going to calculate the percent error. So this is our equation for this reaction. So when you found the delta H for the reaction with calculations, that was if 2 moles of aluminum reacted. You just found yours with 1 mole of aluminum. So you're going to divide that value you just found, divide the value in your pre-lab by 2. So you want it just per 1 mole, not per the 2 moles here. And then that is going to be your theoretical value. So the actual is what you calculated in number 4, minus the theoretical, which is half of your pre-lab, and then divided by your theoretical times 100. And hopefully adding back in what was lost in the calorimeter is going to give you a better value. There is not going to be a formal conclusion. I know your lab says it, but I've taken it off the rubric. You're going to answer the analysis questions, the error analysis questions, do these calculations, and then you are done with the lab. If you still have questions at this point, feel free to email me, or Thursday we'll spend about 10 minutes at the beginning of class going over any questions that you have left. Remember, I'm going to be gone Tuesday and Wednesday, so make sure that you fill out the Google form and that you get as much of this lab done as possible. It is due Friday. We'll see you on Thursday.